a laser pointer. But I thought it was like a lightsaber or something at first. Of course, you have to like open things up and figure out, I'm expecting like, a whole bunch of like D batteries in this or whatever. Not bad. Yeah. honest customs officer. It's just a laser pointer. Yeah. The bag was vibrating much. Anyway, let's see what's over here. Oh, dual screens. All right, well, I kind of figured we'd run this more as an informal back and forth. I don't know exactly what Jeff was looking for with the deep knowledge. I've seen people do it just as they've pulled the questions from their presentations over. I saw that great one, the Firewall 1 one, where they actually were running over so much they continued it in the deep knowledge session. So if it's not going the way you want it to, or you want to take it a different way, shout out and let me know, because this is ultimately designed for you folks. As we're designing it on the fly, you're helping create it. So we finished up over there. We were talking about, and we did the whole approach to a particular problem of finding systems on a network in promiscuous mode. We didn't really open it up for questions. Normally I'm just a loud enough mouth that I don't need the microphone. So I'll open it up for questions now. It's a little smaller environment, a little easier.
You mentioned something in the other talk about sniffing or switch networks.
Oh, okay, yeah. Sniffing on switched networks. Actually, I can show you this was something we did a while back. I'm just going to pull up a different slideshow from a long time ago. If you don't mind, just bear with me. And don't tell my marketing people I'm doing this where you can see it, because you're going to see like old Loft logos as opposed to the new cool at stake logos. They'll be like, my pictures. I hate my nice operating system. It's really useful. Am I becoming corporate yet? I'm going to try and hide this a little more. Here we go. Yeah. And let's see. Yep, okay, there we go. Hey, good. Alrighty, let's see. So sniffing on switched environments, there are a bunch of ways of doing it. One is that I've come across, and if people have other methods or mechanisms of sniffing in switched environments, please shout them out, share. One is that you convince the switch, basically by beating the unholy tar out of it, that it is nothing more than a dumb bridge. And this works more often than not. A lot of these things, if you start thrashing the tables around, such as I'm setting MAC addresses up on multiple interfaces of it that are the same thing, and it's trying to figure out if this is a new user move every single second there, starts thrashing. A lot of them just fail open because they were having problems in the design, and they didn't want to actually fail close. They wanted to say, well, I'll degrade service, but I won't actually go down, because if I go down, then the customer's going to call me up, and I've got a problem on my hands. I've been in large ISP environments where they're running switched, they're running the Cat 5Ks, or they're actually up on the Cat 6Ks now, and you start sniffing on the network, and you don't have to do anything, and you're seeing all sorts of stuff that's not broadcast coming down your leg. Now, there are other mechanisms of sniffing on switch networks. One of my particular favorites is to talk like a switch, because these switches are communicating amongst themselves. If you're in a large enough environment, you don't have just one switch. You've got 4 or 5 that are set up in kind of a full mesh topology. Even if they're not full mesh, they're setting a spanning tree down. They know what everything's hooked up to. And the way they're communicating is through ISL, or inter switch link protocols. They'll either be using a proprietary one, or they'll be using a more universal, 802.1q. I don't know what the IEEE number is for it off the top of my head. I looked a long time ago, and let me explain that this was a long time ago, and I would be very surprised if it was not fixed to some extent at not the Cisco Cat 5Ks, but Cabletron was building at this point something called a secure fast switch. And I just loved it because I had the word secure in it, so I had to go dink around on it. And they had the notion of VLANs, and they were trying to explain, how to keep VLANs as a security mechanism, which I disagree with largely. But by talking ISL, we reverse engineered their interswitch link, their proprietary ISL, we were able to say, hey, I'm going to start talking ISL to you also. Now, when you deploy a switch on your network, most of the time, because you're in a large environment, you got to think of like not you in particular. Yes, if everybody was you in particular, everything would be done right. But of course, everybody is not you, and they're going to do it in the easiest way possible. So they throw these switches out in the environments, and they have to work, no matter what environment you put it in. If the CEO walks, into the conference room and plugs his network in and can't get it because you've said, no, I've hard-coded your MAC address to that one port in the wall because I don't want anybody, messing around with the switch, well, that's a career-limiting move. The CEO needs to have this stuff happen. So you're going to have this thing as a flexible network that can kind of learn on the fly. Well, the other thing is that you're going to sit there and you're going to plug one switch in to the other switch, because that's how they're going to communicate at some point. And as soon as that port sits there and says, oh, I see ISL being spoken, it says, that's another switch. Let's start communicating. Now, it configured that to be a port switch as opposed to an end node switch on the fly based upon seeing particular traffic. Yes, you can configure your switches such that they say, no, this is only a host port. But of course, most people don't do that. They put the things out, they work, they go away. As such, we were talking ISL, and you simply say yes, I want a copy. There was one thing which was beautiful, which was called a call tap. And it was exactly what it sounded like. If you knew of a conversation going on between two distinct nodes in this mesh topology, you could query to one switch and say, these two machines talking to each other, I know it exists somewhere, find it for me and give me a copy of every packet of that stream. And sure enough, it would. You couldn't do it and say, like, give me a copy of everybody's packet, because there's problems with that. If I've got an aggregate network bandwidth of like, a gigabit, I'm not going to be able to put it down my 10 megabit pipe. That was one mechanism of doing it. What I'm going to show you here was a way of simply forcing a switched environment to play man in the middle with you. This was really messy, but it was kind of fun that it worked, and hopefully it'll give you some ideas to maybe improve upon it. And if you improve upon it, please contribute back to everybody else. We don't move forward otherwise. And okay. I get to play with the lightsaber. Switched environments, multiple switches. I'm actually not going to be able to hit it too much. Host A wants to talk to the outside world, and we see the router up and to the right of switch A. Now, when a host moves, you get something called router flap, and you'll usually lose one packet in the switched environment while it actually flaps and says, oh, I've got to move on another port. And then when it flaps back, you'll lose one packet. But while you're still talking, you'll keep the connections going. So I'm host B, and I want to play man in the middle, or of course, if I'm playing man in the middle, I can just sniff. I just don't modify anything with the communications from host A to whatever's in the outside world. And again, for those showing up late, I'm kind of breaking all the corporate rules and pulling up old slides that I haven't redone with the @stake logo. So bear with us. Slight technical difficulties. If I gratuitous ARP and if people aren't familiar with what a gratuitous ARP is, normally when a machine trying to match a layer 2 address to a layer 3 address, it has to ARP and saying, who has this IP address, tell me the MAC address, so that I can send it on the local wire. And you'll either get back that machine's MAC address, or you'll get back the router's MAC address, because it'll say, I've got everything, nobody else knows who the hell that is, forward it out here. And then you send it on over. Or maybe you have some sort of bridge or forwarding thing that's doing those proxy ARP responses. A gratuitous ARP is saying, let's say I'm machine Mudge. Who has Mudge? Tell Mudge. Well, this is psychopathic basically. This is I know who I am. I'm just coming up live. Most systems, when they come live, by default do a gratuitous ARP to say, everybody prime your ARP caches with me. I'm not asking for anything, just know that I exist. So if I gratuitous ARP as host A, switch B does a switch flap and instantly says, I've got host A over on my port right here. So actually, let me back up. Let me say let me gratuitously ARP as the router first. I'll gratuitously ARP as a router. Switch B will say the router is connected to me over here, just a host. It's just an end node on the port. It sends it down the spanning tree, saying, and switch A updates the tables, and switch C updates the tables. Now, when host A sends a packet to the outside world, unless the router has spoken in the meantime and forced another switch flap, it's going to go to me. How do I get it to the outside world? Well, I can't send it to the MAC address because I just said I was that MAC address and forced the switches to think that that's over with me. Send it out what? I still couldn't hear you, sorry. Oh, send out an ARP request for the router. Yeah, I could do that, and then the router or the router will respond, and everybody will flap back. I got an easier one. Try it. Oh, that's a good one. I hadn't thought of that. The router has multiple interfaces fired at a different one. It might be that I can't see the multiple interfaces, and nobody will know how to get it to one of those, though. Because if it's an external-facing interface or something that these switches don't see, they won't prime themselves, and they'll send out, say, inside their mesh, where is it? I don't know. I have nowhere to send it. If I send it out to the Ether broadcast address, I send it out broadcast, it's going to get to everybody in my, hopefully my restricted broadcast if it's narrowed down. The router doesn't care because the router's just going to say, I've got a packet. Oh, it's not destined for me, it's destined for the outside world. I'm a router. My raison d'etre is to forward this packet outside. Now, when it gets the response back and it sends it in, it's going to send something out. Switch A is going to see activity with an Ether address of the router, and I'm going to get this flap back, and it's actually going to say, oops, now I know where the router is. I will have to, at some point, have basically gratuitous ARPed as host A if I want the response. Otherwise, I can just have like a halfway, an asymmetric sniffing situation inside this switched environment. That's one way. That's the difficult way to sniff in a switched environment. The easier way is just force the switches to go into bridging mode. Or as we used to do with Loftcrack, send out an email message to everybody saying like, oh, connect over here. And they just like, and they do the challenge response negotiation, and they send their, SMB packet over. And it's like, thanks, got your password. That's cheating, though. Yes?
The easiest way is to avoid layer 2 at all and just to take over the IP address of the router.
If you can take over, well, the switches don't know. It's not fair to say that the switches don't know about layer 3 now, because these switches have gotten so, unfortunately, intelligent, and I use that phrase very loosely. They make a lot of assumptions by priming their caches. They prime their state tables in layer 3 based upon seeing things in layer 2. They have mappings for IP addresses down to MAC addresses. They break the OSI model by directly intertwining everything all the way up to, basically the application layer nowadays, it seems, which creates entirely new threat models on how to attack these things, because the OSI model was designed to be relatively independent of each other layer. As such, it's difficult for me to just take that IP address, because how am I taking that IP address? It's by telling them that I've got the MAC address and by updating in those aspects. One of the things that I had mentioned in the talk was a curious concern, a lack of understanding on why some of these systems, when I was flooding the network, would behave very quickly, and when I wasn't flooding the network, would behave very slowly. And it was you, correct? Pointed out the solution, so I think you should probably share it with the audience.
It's pretty simple. Anybody who knows, I think it's recon drivers, they say optimize for CPU usage or optimize for bandwidth. What these drivers are most likely doing is they're taking, say, 10, 20, 30 packets, batching them all together in the memory of the card, and then sending them to the operating system at once. It's more efficient for the CPU because it needs as many context switches, but it increases the delay for the operating system to be able to, for example, send back the thing. Now, when we go into promiscuous mode is a rarely used functionality, relative at least, and therefore it doesn't get the same kind of optimization. Therefore, the caching is switched off, doesn't need to occur. the information is straight to the operating system, which can then send a response back at its speed, one by one, which will actually end up being faster than if it had to wait for it to get out of the buffer in the first place. My theory.
And I think that theory exactly explains it. And I'm like, this rocks. Finally, I can sleep again. Considering we came out with Anti-Sniff about a year and a half ago, I'm very grateful. Were there any other questions from the talk? Well, this is going to be a really easy deep knowledge session then. Sure. These here are not available. I just kind of threw that one up as an example of the, this one's got some interesting slides. The ones that we showed on the main presentation should be in the handouts. Feel free to copy it down. That's like the only slide I'm showing out of that one if you need it. The other ones are it's like 77 slides. They're like crypto and just standard, a lot of intro stuff and a few attack methodologies, but nothing really special. Sorry, yeah, go ahead.
Do you play around with overflow and the MAC tables or the switches? We just play with Macs so that you go, it's forced to, since it's out of the add more Mac to the table, everything goes
Yeah, the statement was one of the ways that for switch abuse is, and this is correct, flooding it and filling up its MAC address table, because this is a finite table. They're not growing it dynamically most of the time. I've seen a few that will grow it dynamically, but even then, you have a finite amount of totality of MAC addresses you can fit in there. A lot of times when they hit that threshold, that maximum level, they say, oh, the heck with this, and they go into bridging mode, and they just send all the traffic back out. Now, you might think, well, geez, every time I'm knocking the switch over into bridging mode, everybody's going to notice a degradation in quality. And I've gone over to ISPs and large organizations, and they've been in bridging mode for 6 months, and they haven't even noticed. So, yes?
I'm curious if you've seen any interesting behavior by sending the ether broadcast to LS and then sending the IP address to localhost, to 170.0.1. Because most machines will have a localhost address on them that may or may not get delivered. I'm curious if there's been any interesting behavior out of that.
Yeah, that's an interesting. The statement was sending to ether all broadcasts, but then putting the source or the source and destination, because you want to actually get the packet back from it to 127.0.0.1, the loopback address. I haven't really played with that too much. That would be a good avenue of looking down forward, looking further into. I'd proffer that it probably works. So, unless of course you're going through a router or something, but of course hopefully at that point the ether. Yeah, it's going to drop 127.0.0.1 if it's got it. Ether broadcast would still get it through the router. Oh, that would be good. That would be interesting. All right. So that's the end of the question and answer session, unless somebody has other stuff, and then we kind of go into. Sure.
Could you speak a little more about the selection of appropriate bogus internet addresses?
Oh, the selection of bogus ether addresses is very, to me the criteria was very simple. There were a few things which would absolutely lay waste to the network. And when I laid waste to the network, I couldn't get a response back from the appropriate hosts, hence I couldn't do my tests. Those were the ones we stayed away from. Those usually ended up being multicast. And what signifies a multicast packet is, this has been a long time, so if I do something wrong, somebody holler out. I'm not a proud person. I'm more than happy to swallow my pride and learn something. You've got your 6 octets here. The least significant nibble. So they've got least significant nibble right here. Oh, wireless one. Hey. Over here, if the least significant bit is set to a 1, that signifies multicast. Basically meaning that the first value is going to be odd. something, F like that, or 1. If that's the case, you get all sorts of bizarre responses out of many switches. I'm not a multicast, ether multicast whiz. I've dealt with IP multicast, but I really haven't looked a lot into how these things are trying to deal with ether multicast. It's definitely a potential stress area in your environment. If I'm deploying switches and I'm saying, hey, I'm going to use these for VLANs, I'm going to set these things up such that they are a security perimeter, and I have disparate security levels running on the same physical hardware in the same memory spaces, which to me is a red flag right to begin with. I better understand this thing inside and out on how it's working, and looking at how it handles strange or things that you might not see in your environment but are still enabled on the switch, such as multicast, are prime stress points to look at as threat models for abusing your environment. Sending out bizarre multicast, I was able to crash most of the switches that I had come across. Maybe there's other ways of actually getting them to, join you into ether multicast groups and then, send information back to you for them. I'm not sure. Did that answer your question, kind of? Great. Any other questions? Sure.
There's another way to sniff on a switch network. There have been a few notes like on bug traps. That is to misinform other computers' architectures. It turns out most operating systems that I've tested will accept our response and update their updates even if they didn't ask the question. And so you can tell a fixed set of machines that you are the routers, that your MAC address is the router's MAC address, or is the MAC address for the router's IP. And you can also tell the router that you are particular other machines, and you can be in
Right. The statement was one of the mechanisms for sniffing on a switched environment is preloading intentionally the MAC address tables. And this is similar to what we were trying to do with the gratuitous ARPs. Much like a gratuitous ARP, it was just pointed out, a standard ARP response, even if you didn't ask for an ARP request, will normally seed or replace something in the actual the MAC address table, the ARP table. This is layer 2. Layer 2 has no notion of security in it whatsoever. When you're looking at a switch, which is a layer 2 device, and it's claiming that it is going to be dealing with security zones, this should be, something that strikes you as diametrically opposed in functionality and statements. I'm going to impose security on something that has no security built into it. Well, of course, that's the whole dichotomy and dilemma of internet security, but that's a separate story entirely. Not only can you set it up with ARP responses, you can send out ARP requests. And if I send out an ARP request, another system will actually listen to it, even if it's not the same system, and say, oh, that was type 0804 ARP request in the ether header if it's going to broadcast. I'm going to update with who sent the ARP request in my local tables, even though it wasn't even destined for me and I didn't have the answer. All of these guys are very easy about understanding and believing ARP packets. The reason for this was that a long time ago the networks were a lot slower because it took a lot more processing power on the actual systems to figure out where to send the packet to and to create the packet and send it out. So these ARP tables were set up as pre-cached environments such that once I learn one of them, I can just start sending it directly out. And I want to learn them as quickly as possible in any way so that I don't have to add the extra latency of saying, ARP request who has, wait for a response, okay, now I can send out my IP packet to it. But yes, it's absolutely correct as another way of sniffing the networks. It really turns it into you're playing a passive man-in-the-middle attack where you're just storing and forwarding. Of course, it also gives you the perfect potential of playing an active man-in-the-middle attack and taking the information and modifying it in transit. Yes?
In terms of running a sniffer securely, you were talking earlier about being able to send packets that crash the sniffer. One of the things I've been thinking about to defend against such attacks is usually they attack the parsing component of the sniffer.
Absolutely.
Not the actual packets, not the actual packet pattern. So if you want to do it securely, you run TCP dump as sudo to root so that it can access the device, but you write, -w to write to a file, make the file standard out, then pipe that into non-root TCP dump, or even better, text mode ethereal. None of you have played with it? Play with it. It's awesome.
What's it called?
Ethereal.
Oh, ethereal. Gotcha. Yep.
Richard Sharp's part of that from the Samba group. Anyway, it basically is TCP dump, but it parses everything. And text, so it's really nice. But the idea is that you have root doing the packet graphs, and non-root actually parsing.
Right. The initial statement there, and this is an interesting one. We can talk about different ways of securing and buttressing up on sniffers, and also different ways of trying to knock sniffers off. And some of the problems that people were designing was the way that you disable a sniffer over the network is normally by taking advantage of a flaw in the parsing and not necessarily the actual raw packet capture. Be more difficult to take advantage of the packet capture. I can think of two examples off the top of my head that are very easy. One was Solaris was horrible about this. If you were pinging a machine and you elicited a router response for a Cisco that had set administratively prohibited, it would crash ping. Now, the reason was you got the response, and it was a I forget what the correct terminology for the field, and it was the request type or response type code was a static array for inside the header file for Solaris, and they were indexed up. Now, there were additions put into the ICMP code types there, which one of them included administratively prohibited by, normally like a router, and it was indexing beyond the end of the array. A very similar problem happens with Snoop on Solaris systems when you're playing with ARP stuff. Now, a standard ARP packet looks like it's got the 6-byte ether header. It's got the, I can just draw it up. It takes 2 seconds. Easier to visualize that way. Lose the black one somewhere. Yeah. Blue would work. So if I've got the 6-byte destination source, and I've got a 2-byte opcode, ether dest, ether source, type. And my type ends up being an ARP request. You have ARP requests and reverse ARP requests being the two separate types. Inside the ARP request, I have ARP request, ARP response. Oops. So here's my ARP packet. I have a type field in here, which ends up being, it's a 2 bytes also. I can't remember, it's not the exact first thing, so I'll just put it over here. Whoops, type. Great, somebody will look at this later on, looking at the real packet layout, going like, what the hell was he talking about? Anyway, it's a 2-byte type, and as such, the 2-byte type can go up to, 16,556, right, 1655, yeah, 16 bits comprise it. The only values that they use for it, even though this type code has said whether it was an ARP request or an ARP request or a reverse ARP request, because they're handled differently. One is normally a userland process, which is a RARP, is inside the ARP packet. It's ARP request, ARP response, reverse ARP request, reverse ARP response for values. Well, what happens when I set this thing to 500, 600, 752, et cetera, same thing. They index off because they were looking up for a table for the string to actually pull out. Now, the interesting part is what happens when you start doing this on various switches and you start cycling through the different type of invalid ARP types. Or you start matching up and say, this is an ARP response and the type was a reverse ARP request packet. You start playing this way and you can get some really interesting behavior outside of these switches. And that was one of the tools that I wrote and posted to BugTrek a while back called grad ARP. I think there's even like a link to it somewhere. I should put it up on the main site. I'll make sure it goes up on the @stake website under like a tools section. That was a long little diatribe on that, but so sniffers. So what would be some ways of actually protecting against these sort of attacks? Maybe you're a sniffer writer. Maybe you write something like NetX-Ray, EtherPeak, or your TCP dump developer. I mean, let's skip the developers. What as you as a user of these sort of things, will help you. Let's say because you have to role play in order to do like the War College stuff. You're the malicious attacker here. Well, you're not going to do DNS lookups now. You're not going to have it do extra filtering inside to try to do protocol analysis, because I just want it to do raw packet dumps down. I'll create it later on my own. I want to make sure the thing's running. Are there any other things that we can think of? Maybe I'll look at the network load, and when the network load starts sending out packets that I don't think map to anything real, I turn myself off for a few seconds to increase the latency, or decrease the latency as the case may be. This is the cat and mouse, the arms race type game. How do you defeat any sniffer?
One specific thing that comes to mind, I can't remember the name of the project, but it's essentially encapsulated the entire Linux 2.0 networking stack into a library that you can throw raw packets at. Primarily used for TCP packet reassembly, so that your IDS that you're building, Libnit, which one is it? Do you remember?
Libnit? Is that it?
Well, the point is that half of it is you can go.
Oh, you mean Mike Schiffman's thing? Libnet? Yeah, off of, I'll give a nice plug for Mike. Mike did a really nice job on this. Packet Factory, is that what it was? Packetfactory.net or .org? Try one of the three, com.org. It's
Just the point is, half of it is you're throwing packets at it to reassemble them. The other half is you can probably eliminate nowhere near all, but a good number of completely invalid packets just by seeing if they'll get through a standard TCP/IP stack.
Yeah, that's a good point. What we tried to do inside the three-way handshakes we were creating is we made sure that the checksums worked. We made sure everything else was real, because it would be a little too easy to discard them. It might be that you just hadn't brought a thought to me. One of the tests was just sending nothing but SYN packets with that were going maybe to port 23 to try and exercise telnet sniffing programs. And of course, these guys were trying to malloc memory, or else they had a finite state table or a finite statically allocated array. And by just absolutely blowing that buffer on them, that would knock it down. So we might want to be very careful when we're designing the sniffer. Not only do we not do the DNS lookups and everything else, but we want to make sure that we're, if we malloc and malloc fails, because it will in this case, that we're not going to behave poorly, or that if we do fill up our buffers, we can do the same thing that came out as an attack response for the SYN flooding, which was fast parsing or increasing the parsing, not keeping them waiting for the SYN ACK that's going to follow indefinitely. Sure.
I think incrementally building filters, when you take over hosting in one of the PD, there's arms that
Oh, anti-sniff, yeah.
If you wanted to be anti-sniff, I believe it would be possible to, after you take over the machine, do traffic analysis first. See what are real MAC addresses they're using 80% of the time. Build a MAC table out of those.
Now he's thinking.
What protocols you want to take out.
Yep, absolutely. The statement was incremental filters, because if I'm building an incremental filter by watching the networks, and all I'm doing is I'm not trying to grab the packets at this point, I'm just trying to say, which ether addresses am I seeing here? I will do that over a period of, let's say, a week of standard utilization. I'll nail most of the machines. Sure, somebody will plug a laptop in here or there, and I might not get it. But now I'm only going to watch for those particular MAC addresses, because I know the finite reality of my universe, which is the local network. It's going to be the machines on here, and then it's going to be the router, MAC address that I'm always seeing. And if I see stranger stuff than that, I can either hide, I can go off, I don't parse it, I don't process it. This works very well if you're in a controlled environment. And unfortunately, most networks that we're in are so dynamic and there's so much crap going on. We've got transitory networks where all of a sudden I've got multiple nets living on top of each other. I've got 192.168 on top of a 172.16 network, because they're both sharing the same physical cable for some sort of linking or long trunks. And you start seeing all sorts of problems in large organizations. However, that's never a reason not to do something or take an incremental step forward. And as such, if you're in a particular department, this will probably be a really good idea to do. Let's see. Sure.
One thing you can do is you can filter off the only data packets instead of looking at the pins, you send the pins and the acts. Because really all you care about is the data at that time. So you can use a VPL to get rid of all the handshakes and closures. And then also only record those things that you responsibly use. That's how an IDS works.
It's how some IDSs work, yes. The statement was you could just look at the data packets and ignore the initial three-way handshake components or the components that don't have the data portions to it. Now, let's role play as a threat model. I am, or you are, at this point, a malicious attacker, and you're designing, and this is how you wrote your sniffer. What is the problem in the information that you're trying to gather? You're stateless and you don't know where the beginning of the session was, and you want the authentication component, because that's most of the time what we're actually looking for is the authentication component, and that's going to be hopefully at the beginning of the session rather than the end of the session. You know, I did all this work. Are you really Mudge? It's like, sure. Yeah, I thought that was a very novel idea on how to on what some of the intrusion detection systems actually approach the problem with.
Stateless analysis like Snort.
Yeah, stateless analysis like Snort, and that's good if you're looking for if you're just doing a regular expression or a pattern matching for large streams, but you really don't care when the finality is or when the beginning is. Speaking of stateful or statelessness, one of the things that wasn't commented on, and I don't know if people are aware of this, but I thought it was relatively cool, in the Firewall 1 talk the other day, is how Firewall 1 actually manages its state table. And if it was talked about, please, stop me. I don't want to be going over something else. It builds the state table, and it has a timeout value in it. And the reason state tables are so important here is that all these switches are just state table mad right now, because they're doing a state table for the data layer, they're doing a state layer for the network layer, they're starting to do state layers for the transport layer and for the actual application layer, and they're starting to say, if I see an ARP request, I'm going to set aside a piece of memory for the IP address, because that's going to be coming shortly hereafter, and on top of that, if I see the IP address and it's going to this machine, I'm going to start setting up TCP or UDP handlers and holders in here, because they're starting to try and do layer 4 application switching and all this crazy stuff. And it's like, what do you mean layer 4 switching? This is anyway. But so state tables are very, very important in this, and this was, I thought, a very clever way of doing it. What the Firewall 1 box does is has a state table, has the source destination, and the timeout value, and I'm minimizing what actual components it uses inside there. And let's say it times out, and it gets another packet that's coming in, and it checks its state table, and it doesn't exist anymore, so it can't sit there and say, oh yeah, that's part of this session, I'm just going to pass it through, I'm keeping state here. What does it do? Sunscreen will just sit there and say, I timed you out, you're not in my state table, get the hell out of here. Of course, sunscreen also costs $50,000 per box, so you're not going to be deploying those on your local Class C network. What Firewall 1 ends up doing is it takes the source and destination address, let's say it's TCP because that's what it's probably keeping state for. It'll take the sequence and acknowledgement numbers and munge them around and actually and strip the data off and then send the packet to the destination node. So it's an empty, it's a dataless packet with the wrong sequence and acknowledgement numbers, but the correct IP addresses, because it's trying to figure out if there is still a state there. When the end node responds, it'll either respond with a reset saying, I have no clue what you're talking about, in which case the Firewall 1 box says, nope, there was no state that I had timed out previously here, so I'm just going to drop this, this packet. Or it'll get an ACK back saying, no, this is the sequence and acknowledgement number I'm expecting, which, by the way, is all the information it needs to reset up that state table and then forward the communications back on, which I will also proffer as an exercise to the reader is an avenue for attack. Let's see. Any other questions? Sure.
I was going to say that the problem of getting around anti-sniff and the problem of sniffing on a switch network is somewhat similar, and you could also do the man in the middle thing and not go into promiscuous mode and do your sniffing that way.
That's a very insightful statement. The statement was the problem of defeating something like an anti-sniff or something that's trying to detect the promiscuous mode environments and the problem of sniffing on a switched environment are very similar. And by forcing a man-in-the-middle type environment, you don't actually have to go into promiscuous mode in order to do the sort of sniffing. Now, you still might have to be in some sort of mode where you're going to be able to read the packet even though the IP address is not on you, but it's going to the correct ether address, so you have to do a handoff somewhere. That's a good way, that is a good way of approaching the problem, is figuring out what other environment is similar, and if I already know vulnerabilities in that environment, how many of them can I parlay over to this one? That's one of my big goals in life, is trying to help people see problems in a particular area and then take the ways that they were done and look at other areas where they might be gone over. So you just made me very, very happy. Is there something? Yep. Oops, sorry, here we go.
Most of the new network hardware, too, allows you to say, I want to listen on these 64 MAC addresses, and then forward it up so they can send interruptions for those.
For NICs on regular PC?
Yeah.
Whoa.
The DEC tool chip does it.
Oh, that's news to me. Okay, so the DEC tulip chip and apparently other chips will allow you to set up a list of particular MAC addresses only that you want to be in promiscuous mode for. Wow. Why? I think somebody has an answer to why here.
It's called the multicast address type. It's really how you put up.
Oh, of course.
There's no restriction.
Yep. So this is to aid and abet in the multicast traffic going back and forth. For I've joined a particular multicast group, and as such, I want these particular addresses. Oh, very clever. So let's see. That gives us a new way to actually start to exercise the latency by really starting to pound on multicast addresses to figure out. We can not only figure out who's potentially sniffing, but we should be able to, based upon latency, figure out who's in which multicast group or who is actually participating in a multicast group at this point. I don't know if that's useful information in general, but it might be in a particular environment that I need to know who's doing what particular communication or talking in a group, or who's listening to a particular broadcast.
Supposing I'm trying to avoid anti-snip, my absolute successful strategy of thinking about it is I just don't respond. I basically firewall my machine completely against the network. You have no latency to measure. You have no differences to measure. Essentially, the only way you know I exist is because my port is live on the Ethernet side, on the layer 2, but there's no communication past that.
Yeah.
Now, my question for you is there an Ethernet ping mechanism that exists in this pattern?
No, I did not find the equivalent of an Ethernet ping that exists in the equivalent. Statement was one way to avoid anti-sniff, and let's see if I got this right, because I have another way of detecting that, is to basically just shut yourself up, and you're not going to respond to anything. You're just sniffing, you're pulling it in. This is very similar to saying I am if configuring my device, if configuring my interface without an address, but I'm still in promiscuous mode, so I'm still making copies off of everything. Well, keep in mind the threat model that we're trying to address right here, which is a machine has been compromised, and of course, if it's compromised over the network, they attacked it. Let's say it's the intranet web server. How do I detect that they have done this now? The internet web server is down. I can't see it anymore. It's like, Bob, I think we lost the R&D server. It's like, which, by the way, is how we talk over at Stake in the R&D group. It's like, yo, Brian.
No, but you've got all these machines that'll have multiple Ethernet cards for either load balancing or for any other purpose. Essentially, you're going to compromise the host, you knock out the load balancing, the system still appears to work. You've got one thing shut up on promiscuous, you've got the other acting completely normally.
Right. Well, and to counter on this, and this is a very good discussion, because this kind of shows how do you approach the problem, and how is the problem then a new problem to go after. Multiple interfaces that are doing load balancing for a particular thing, and all you're doing is turning off one and sniffing on it. Well, the problem is much like, let me pull up the other slide. Clowns, mostly clowns. Yep. And I'm glad I put this third one in here now.
If you were connected to a switch, if you shut off network traffic, surely the switch might drop you from the ARP table.
Yeah, it's nasty when the switch drops you from the ARP table, especially if it decides not to relearn who you are because you're already gone. And I've had this problem multiple times. This is another problem with trying to attack some of the switches and talk their protocol language and communicate with them, because if you say the wrong thing, they'll believe you. And a lot of times that's like, hey, my port is, uh-oh, I lost the world. For the problem here, I've got a machine with multiple interfaces, and what we could actually do is say, hey, I've actually got multiple interfaces down. You don't see my mad PowerPoint programming skills. Woo! I've got multiple interfaces down here, which is kind of like the load balancing thing, even if we virtualize this to some extent. If I turn interface 1 off and it's just in promiscuous mode, and interface 2 is acting normally, when I flood the network and interface 1 sucks all this information in, I still see the latency on interface 2. Because now I'm just going to say, hey, I can't touch interface 1, but that's okay. The machine is what's demonstrating the latency because it's doing all the parsing. This is what we're doing here, where we have host A acting in collusion. I can do this. What the heck with it? Oh, you should see me in Visio. What we're doing here is A has no way of communicating with B because B has done exactly what you've said. But C can communicate to A, and C says, on that network, flood. And now I'm going to check every machine on my local network to see who's dual home to that. An interesting point is this problem is not too much further off, and I can't mention too much about it because I did it a while back on a contract for somebody else, so they own the rights to it, for discovering machines that have dial-ups connected without knowing what the dial-up component is, which is always a nasty way of bypassing your firewall because you've got somebody who just plugged in, went to Radio Shack and got the digital to analog converter, so they're hooked into your PBX, and they've dialed up to AOL at the same time that they're inside your corporate network. Yes?
Going back to the example that you're talking about with the load balancing across 2 Ethernet bars, one thing I've noticed with Linux is even when you take down one of the interfaces, the packets still go through. I was wondering if you had any comments on that.
Without starting the holy war, my comment on how Linux handles its networking traffic, this is my only gripe against Linux. I am an OpenBSD type person. It is nothing against Linux other than the fact that I need a real networking stack. And Linux for a long time didn't have one. They didn't have the BPF components. It was always, it's coming, it's coming. It's here, apparently it's here now. I haven't tested it out. I'm going to give it a little more time for some other people to beat on it. I'm more than happy to use it as much as anybody else. I have no clue why they did some of the things that they did inside there. If you look at the LSRR source code for a while, which is the loose source routing, it was /* to be done at some point */, but it was the actual function. So it's everything else looks like it's actually calling it and doing the right thing. Frustrating, but it's not that there's not stupid things inside of BSD. I mean, you know how to find all the BSD problems. It's just grep for XXX because they document themselves. XXX, this is a buffer overflow that's probably exploitable. We should come back and fix it at some point. XXX. A close friend of mine over at Stake, Dave Goldsmith, had the great line, and it's kind of dating, the people that we used to talk with all the time, was the old 8LGM method of finding, if people remember the 8LGM group, finding bugs in source code is that, like grepstar.c Eric Allman or grepstar.c Vixie, and always look for self-documenting bugs. Yes?
Say too, reducing latency. A lot of these big web servers have a lot of processors. Just set the infinity under capture thread, 1 or 2 of the processors, and then the kernel still has time to respond to everything going back at it.
That's clever. If you've got threads that are actually doing the binding for the actual sniffing, is set the priority on them down and let the multiple processors handle it. Yeah, when you hit multiprocessor boxes, this is a very important point because we had a couple multiprocessor boxes over in the labs that we were beating on, and certain ones really didn't load balance internally with the kernel tremendously well. Some did it wonderfully well. And the ones that did it wonderfully well, if you had enough processors and you had one handling, all the sniffing stuff, a whole bunch of other stuff was really good at just going yeah, sure, I'll respond. It's going to be very difficult for you to introduce serious latency on me because I've got so much horsepower going here. Now, it was, you'd expect it maybe to really prevent the latency introduction, but when you're doing that kernel switch into user space, you're still doing a nice hefty context shift that's going to affect, no matter what the affinity is, across the different processors because you've only got one instance of that kernel and when they're trapping back in and out. That is very expensive to do. We'll go way in the back here and we'll come up here.
Going back to what you were talking about at the beginning with using the passive random middle to get around the switches with the arms. Can you do that in a VLAN environment, forcing the switch to break out of your VLAN? Can you do that, or?
The ways of forcing, the question was how do you get out of a particular VLAN, since we're over on the switched environment now. Yes, sometimes by simply ARPing and saying I am the MAC address of somebody in this other VLAN, it instantly says, oh, port X is now VLAN 100. That's problematic. VLANs were designed to minimize the amount of broadcast traffic. They were not designed to be a security mechanism. They are being redone somewhat. If you look at like the Catalyst 6000s with, and they were calling it internally like the silent VLAN. I don't know what it actually is called now in the release ones. They're trying more and more to make it such that it is kind of like a self-contained environment. This is good as long as you understand the level of security. If you don't understand, what you're really dealing with, you get a false sense of security and you say, oh, I've got two separate, this is like having two separate actual physical networks. You're dealing with the same memory and you're dealing with the same components inside of this. This is a step up in security for VLANs, but keep in mind that they are not, if you're really conscious about security, the solution there. Other mechanisms for switching VLANs is talk to the switch as another switch and just tell them that you're in that VLAN also. They listen. They put it in there. I think I was skimming through this, and I haven't read it. It does look good. There was a couple pages talking about, here are other mechanisms of like popping around inside VLANs, and it's very similar to, either flood it over, tell it you're in that VLAN. Tell it the message you have is a tag-based flood message. A tag-based flood message means it's a prepended header that's for the ether packet, and it says, I'm a special ISL, this is my encapsulated payload here. You send this down every link of your, switched environment, and it sends it down all of its, and then it sends it down this inner switch link to the other switch, and the other switch has to do the exact same thing. You get a partner in crime on the other end that's willing to receive this message, because of course it went to everybody, and encapsulate one back up in another tag-based flood message, and now you're communicating outside. You're out of band of all the VLANs in this thing. It's noisy and you're broadcasting it everywhere, but you've broken the VLANs. You can have two separate VLANs, and now these two hosts are talking to each other. Yes?
Back to breaking anti-sniff.
Yes!
Yeah,
back to breaking anti-sniff, and a quick one. You could of course take advantage of the buffer overflow that I had in it.
Actually, that's what I was going to mention. You could also do a preemptive filtering. You could take the SNMP counts for the traffic thresholds that are under normal mode, and if it ever raises above that, you just stop sniffing.
Yeah, that's a.
When you flood the network, it's ignoring.
Yep, which is, and the nice thing is you don't necessarily have to be running this yourself. You just look for another partner. You are not an isolated island in this environment. You want to take advantage of everything that you have around you. If your router is running SNMP and you have an MRTG or something on it or anything else, ping the SNMP daemon. Get the information back. See what the statistics are. If you're seeing an anomaly or a big spike in traffic, turn your sniffing off. You don't have to just query it yourself. Use anybody else that's around you. Heck, that's just saving you energy and time. Actually, was there somebody back there? Was that no, not a hand? I know it's kind of like the four people here having a discussion. Oh, holler out! I'm blind.
You've been reiterating that we don't need to be going to detect things 100% of the time. You keep saying that 90% is great. So on the flip side of that, isn't there a corollary saying that we don't have to hide 100% of the time as well? So what kind of methods do you use to determine how well to hide? We hide the noise.
The statement, and a brilliant statement is, I've said many, many times that you don't have to hide all the time, or you don't have to be successful all the time. You just have to be successful a majority or a good portion of the time. Heck, sometimes you only have to be successful once in a while, and that's good enough. If I catch one machine that's in promiscuous mode out of, an entire flat class B, and that machine was broken into, even if there was 100 other machines that were in promiscuous mode, well, now I know somebody was able to get through my security perimeter. All I needed was that one. I didn't have to get 90% success. I just had to get above 0%. The corollary to that is, if you're on the other side, when you're trying to hide, you don't have to be successful 100% of the time either. You just have to be successful most of the time. And I will proffer that by not even hiding, you are successful most of the time right now, because, how many people are running Anti-Sniff? Anti-Sniff was a little research project that I did while, I was, sick with the flu, probably doped up on cough medicine. It's like, woohoo, we've got it deployed all over the place. And even as such, this is pretty much a proof of concept type tool. You're going to hide from it, 1 out of 10 times maybe. It's pretty good at certain instances, but I'd say 99.9% of the time you're on a network that people aren't looking for this sort of thing, because they're still sitting there going, I'm going to scan it with the latest scanner, looking for known vulnerabilities, and of course if the machine's compromised, those have already been patched, because you've patched them yourself. One of the big problems that we used to always see on machines was, how do you tell if the machine has been broken into? Because it's running perfectly. The log files aren't filling up, the thing's not crashing, everybody can get access to it. Everything else around it is sitting there crashing left and right. I've got to go into var out of messages and remove them every day because the things are getting so big and it's choking because it's only got one partition. This was hilarious. And of course you can also, you find those machines that are running great, and then you can find all the latest software that you've ever wanted. But but then again, hey, there's a new mechanism of detecting it, and looking for anomalies. If I can take a metric of all of my network, and I see that 75% of the time my machines are actually filling up, and I have to do particular maintenance on them, and there are a few spikes in there that just say these machines never have problems. Well, there's two things I should look at. One, boy, I want to reproduce this across these other machines. So maybe I, invite these hackers or whomever to actually compromise everything else so my networks run better. But then two is, maybe there is something that I really need to understand what's going on.
Say that's the real reason script kiddies are so bad, is that they don't have the skills to well administer the
So we need to put out sysadmin 101 for script kiddies courses or whatever. Okay, you won't be so bad. Oh, that's brilliant. That's beautiful. Well, okay. Well, I think we've kind of beaten the sniffer thing around, because we've looked at the technical side of it. We've talked about switches. We've tried to hypothesize on how to do particular new attacks or defeat the particular defensive mechanisms for it. This is a war college mentality. We're looking for new solutions. We're not waiting to see, oh, and somebody did this, and that's how it works. Well, yeah, you want to learn that way, but we want to figure out how to do those things before they do even. If there are any other questions that aren't necessarily related to network sniffing or to anything like that, I'm more than happy to answer them, or we can stay on this.
One of the questions I wanted to ask you, when you said yesterday about the need for war colleges and the need for organizations to think about these things before they happen, what's the practicality that I'm thinking of the little guy? Maybe a large corporation can afford to fund things like that. And to be frankly honest, I think, here in this room, there's a large percentage of the security talent in this nation. Do the average layman, sysadmin, network admin, do they have the skills in order to do this? And given that information, what could you propose to help so that we can help the little guys?
Yeah, that's a tough one. You're absolutely correct. It's the large multinational conglomerate organizations that are really going to do the war colleges, whether we like it or not. If I pick, conglomerate X, they are going to look at their infrastructure and they're going to try and find out ways to break it so that they can defend against it. And they're also going to find out ways to break it because they know their competitors are using similar things. And, maybe it's industrial espionage, maybe it's corporate type stuff. They are potentially, more likely to be on the offensive than somebody else, even some of the government nations, because of the, backlash that they get when the governments actually get caught doing those things. How do you get the little guys to be empowered to do a war college? I mean, one of the reasons that the Loft joined up and merged with At Stake was so that we could really take it to the next step. We are going to continue to try and put out the information. I think this is the type of war college accessibility that, the people in this room, if you're not in one of those, groups in a large organization that's really funded to do this, you rely upon security focus, the bug track lists, the stuff coming out from, our research labs, because we're always trying to make sure that we remain, that it remains publicly accessible to people, because that's how you really change the environment. Sure, we could hold back and just sell the information to particular places, but what good is that going to do? I'd rather elevate the entire level up and have people play on a new playing field and move forward, rather than say, oh, out of this pie here, I'm going to take X chunk, precluding it. But no, the average small person isn't going to have access to this sort of stuff. We're doing delitting of ICs. We're doing heavy optics to actually trace inside of them now. We're doing spread spectrum frequency counting and trying to figure out hopping mechanisms for different wireless mechanisms. That's not something that you're going to walk down to the store and say, oh, well, geez, we hooked this thing up. I need a $35,000 spectrum analyzer. That's part of why we joined in the other company, because we were like, we want that spectrum analyzer. And now we have it. But there are smaller things, and a lot of it is the awareness, and then taking this mentality. And Silicosis will kill me for this, because I'm kind of preempting something that he's going to release. But he walked into an environment, so I'll try and abstract it so he doesn't get too mad. I want happy people working for me. He walked into an environment, saw a wireless network that was set up. The company had never set up a wireless network. They didn't know that they had a wireless network set up. So he found a way of compromising various components on it through this wireless network. Can anybody think of an organization that doesn't have a wireless network? Just think of something off the top of your head. No, just doesn't have a wireless network. Does your local network? Does your ISP have a wireless network? Does your ISP have laptops installed some places? Do they have ERDA ports? Are they using Palm Pilots? Do they have ERDA there? That's wireless. Do they have printers that you can walk up with your Palm Pilots or with your laptops and talk to? That's wireless. Do they have, you name it. Maybe they've even got the airport cards in the Macs. Maybe they've got, it's amazing what's actually running and people aren't looking at. These are all stress points and threat models. And you sit outside, you might not be able to get to it because it's an optical wireless network. But you walk inside, and I didn't even plug into the LAN, and I've compromised your switch.
As you know, the White House recently started kind of poking around at how they can increase the number of PhDs in the computer security field. I'm kind of curious if you have any thoughts on how your war college concept can be applied to the academic level.
Brian Miller's doing that for the Office of Science and Technology program, and I think this is a really good idea. I'm a bit concerned by some of the directions they're taking, but then again, they asked me to participate in this for out of the box thinking, which I'm more than happy to say things that they might not agree in. I got in a little bit of trouble. I was asked to go to the House and Senate Joint Judiciary Oversight Committee, where Michael Vadas and the FBI were asking for $2.6 billion to put more cops on the beat, as it was, to protect an environment that was houses without locks. And I got to say, I don't think you should give them the money. So I don't have a problem, speaking my mind. I'll probably have a problem living past the ripe old age of 45, but how do you get more people educated in this field? And does the war college mentality work towards that? And I think that absolutely that is one of the main directions to go. I don't believe it's how do you get more PhDs in the field. I'm very concerned about that. This is how do we get the NSF, the National Science Foundation, to kind of break up the old boys network and really do we get more information warfare, information security, PhDs in there. Well, for a PhD or for somebody to matriculate in that, that's about like a 6-year program, and then you're going to be doing studies after that. How much does the environment or the industry actually change in 6 years? Well, for the technical and for the tactical components, it changes extremely rapidly. But for the Army War College components, for the way of thinking, it doesn't change as rapidly. However, that being said, I think it changes much more rapidly than 6 years. So when you get the PhDs coming out of this, they're going to be able to do real problem solving at a very high level. And that's very good. And that's very much needed, and we do need more of them. But I think we need these people that are in between. we've got plenty of people coming out and they go through like the little technical courses, or they go through like a SANS thing, or they go through like a sysadmin, training course from somebody else, and they're very good at tactical responses, and they might understand how to do, deploy or do remediation in a relatively quick fashion, but that just doesn't scale entirely. At the other end, you have the PhDs, which are looking at this, how do you solve this entire huge conglomerate problem, but it's abstracted so much that it's really not helping the day-to-day work. Right in the middle is that Army War College thing, and it's severely lacking. And I think that's where we really need to, how do you get people up here, and how do you get the PhDs down here? One of my solutions is that you invite people in the industry, you invite Marcus Raynhams, you invite Casper Dix, you get Whit Diffees, you get Bill Cheswicks and Bellavins, you get people like myself, and you put them over at colleges for about a 1 year, adjunct professorship or something. And it's because you try and beat into their head, this is how you look at problems. So it's part of the PhD thing, and it's part of you look at problems based upon what the hell's coming down the road right now. That's my rant on that. But I think it's amazing that the White House is looking at it this way, and that they're willing to embrace these sorts of ideas, whether they accept them or not. I think that's a good step in the right direction from our government. Sure. No, I haven't. That's a very clever idea. Looking at the information that's put in at the trailing from the malloc area from the user space to figure out if it was all zeros or if it was something else, and maybe you can actually map particular implementations to say, oh yeah, these by default grab memory in this area and it's usually filled with garbage, and a garbage packet garbage at the end would signify that it's good, and something that's cleanly formatted and filled out might signify that it's actually maliciously crafted. Very good point, and I haven't thought about that. Yeah, sorry.
You talk a lot about having corporations have more knowledge work for a large corporation, but for your folks, I'm not talking about something like that. Have you ever thought about something that's like a public war college or something like that, where you open for people in college, stuff like that? I mean, a lot of stuff that's coming out nowadays is coming out from 19-year-old kids from Germany. They don't work for large corporations. They don't have the money to have non-different operations in the basement to play with. I can see good and bad things from out of what you think good outweighing bad, or
I'll give you two thoughts on that, and these are, of course, all of this stuff is just my personal opinion. The first thing is, you mentioned you're only 23, so you're not going to be able to do those, that sort of thing. Don't tell people your age. I never tell people my age. I've had people, tell me that I'm 42, and I've had people tell me, depending whether I grow a little facial hair or not, they think I may be 22. But what happens when you don't tell people, this is a personal, I really love this one, when you don't tell people your age and they don't have that to go on, and you just show them information, they'll put you at whatever age they need to in order to make that information most valuable to themselves. That's honestly how it works. So yeah, do good work and don't tell them your age, and they'll make you whatever age they need you to be.
where you have, people from various countries, various age groups, various backgrounds. And I can see good reasons, I can see good things coming out of that, I see bad things coming out of that.
Yep, the Public War College, there are a couple ways that people have tried to do it. One is like the Cyber Underwriters Laboratory, where it's like an official thing set up to do analysis, to do destructive reverse engineering techniques or offensive research on it. And then there's the other one where you do it as a small group amongst people. This is what the Loft did. Loft had no money per se, because we were basically we were just doing R&D for R&D's sake to try and come out with, this is how the world works. And when the world doesn't work the way we want it to, we want to try and point it in the right direction. Of course, so that's one option you can do, and the Cyber Underwriters Laboratory is another one you can do. Yeah, there's good and bad to it. I mean, heck, I'm we did nothing wrong the entire time. We were under the limelight and the microscope since 1992. If you think we were breaking into systems or anything like that, you're crazy. I mean, I had to go through, I don't know how many NCIC checks in order to go through various White House tours, be dealing with these people, and still the media will look at the work that we did and say, like, well, they use handles, they don't tell you their age, they must be, they must have some sort of malicious intent. And of course, then that's the old school. And you know what? They don't bother me because the old school is still stuck in the old security model also, and they're going to crumble and fall down. And you get these other people that are looking at it and saying, all right, I'm looking at the information is valuable, the way it was presented was appropriate, it was not, intended to be malicious. Sure, some of it might have been sensationalistic a long time ago, just to try, as in an event, and I will humbly, and people can tell me I'm wrong, put forward that a lot of these other groups being able to put out advisories and not be looked at as and demonized so much is because, we made the effort and really tried to be public about it and keep doing it out. And we took our lumps and bruises for it, but I think other people that follow down that path don't have to go through as many lumps and bruises because of that, and that's a good thing. So yeah, it's a dangerous thing to play, but that's the only way to do it for free. We had the members of the National Security Council come over at one point. We were doing some stuff, and we were terrified. We thought, they were going to try and set us up or do something. Here's these suits that talk directly to the president. And they walked outside and they started talking amongst themselves. We came running out and saying, no, you can't do that. We know you're going to talk about us, afterwards. We were really, really nice, and we extended a lot of trust to, to let you see what we were doing and come in, basically to our quote-unquote house. If you're going to tell secrets, you have to tell us what you're talking about. And they said, well, what you did here terrifies us. I said, well, why? I mean, you've got funding. You get other people to do, amazingly, crazy stuff and research. He said, oh, yeah, I mean, we have stuff that, puts this to shame, no problem. But the thing is, you did this without any money or any funding whatsoever. So it can be done. That changed their threat model. So, any other questions? We're probably going to wrap it up then. Oh, sure. I'm blind, so just shout out.
Education for a second. It seems like the vast majority of academic and corporate research that's being done is on new policy models and new systems that are completely orthogonal to any real-world security problems. How do we get new systems built that are actually solving the problems inherent in just 30-year-old protocols that haven't been touched in so long?
Yeah, the statement that we keep coming out with policies, and policies are wonderful, but how do we actually fix the systems that are being deployed based upon the broken protocols? When the analogy is when the Army needed a military transport vehicle, they consigned the Jeep, and the Jeep was built. And when the Jeep no longer met the functionality and purposes, they didn't go out and put monster truck tires on the Jeep and jack it up and put like the rebel flag and ride over things. They said, no, I'll go to the Humvee Corporation and consign the Hummer. It's got different functionality. Well, the problem is we can't really do that with the internet because it is working, and people have all started to rely upon it right now. And I used to say the internet wasn't designed to do what it's doing right now, and I actually go back on that, and I disagree with my own statement now. The internet, it's like if you think about a table is designed to hold stuff, and you can put stuff on it, and the internet does that wonderfully. The problem is we're putting a 10,000-pound anvil on top of this small little coffee table now. So it's not that it doesn't do its design, it's just that we've absolutely overloaded it and need to look at things. One of the things that concerns me is that people do start looking for how do we build the secure system, or how do we put the thing on top of this that'll be deployed correctly and safely. And oh, the evil Microsoft, coming out with their operating system, and it's always so insecure. They should come out and secure it and put it in the most secure, format possible. That's impossible. They can't do it. They'd go out of business. Because if they actually, if they come out and they latch the thing down and they filter things off and they presuppose what is good traffic and bad traffic for you, they're in a support nightmare, and it doesn't work where it's deployed. When I look at, because it's threat models, when I look at a bank, it's got a different threat model than when I look at a university, than when I look at a motor company, than when I look at somebody doing, home gaming. And you know what? Microsoft has to have their operating system work on all of those little areas there. And if they had to come out with different builds for every single environment, they'd lose it. And on top of that, You get people that are sitting there going like, I have my machine as a home gaming machine, which has one security ramification on it, and what you need to allow in and out, which is everything, but at the same time, you don't care because, they're going to steal your games. Maybe you'd care if you're a good citizen that's, they might launch an attack from your system, but most people aren't thinking that way. But then you do your home banking on the same system. This is a completely separate, or again, orthogonal, security model to the other one that you had. And I don't think there's a way of coming up with the secure operating system. I think there's got to be some way of coming up with, here are the best requirements for modeling your particular environment, and then maybe pushing those out. But it's maybe not all the way up to the operating system vendors like we think it is. I'm not saying that they're exempt from doing the right things, and I do agree that they're not doing the right things right now, but maybe we need to take the slant in a different direction.
Just as a comment, going back to your mention about, possibly, the suggestion of using adjuncts as professors at universities, I think that's a really great idea, and I think one of the ways that would really go far towards that, and I know it's been historically considered tasteless, but corporate sponsorship of courses at universities. That's actually worked in a couple situations. University of Notre Dame is one of them, where they rolled out some practical type courses, and they actually asked for sponsorship from folks like Sun to provide equipment. And it was like sysadmin 101.
Works in junior colleges, not universities.
Why doesn't it work in universities?
Because you have to have credentials.
Oh, well, they weren't teaching anything, they were just sponsoring, correct?
They were sponsoring, yes.
That should work with universities. Heck, MIT is basically owned by Lego. Well, yeah, I mean, that's actually a good idea, and maybe that's something that people can take back to them with their particular organizations. I mean, I know at Stake, I'm actually trying to, to get us to fund and to foster and to, support various movements and academic things, and when we're looking at various ways that we can be involved with, things like SPAF's, Sirius type organization. I don't know if that's necessarily the right one, but we're looking at these things saying, how do we contribute back to the environment? Maybe this is a task for everybody else to go back and say, what Lego does over at MIT is they basically fund the Media Lab, and the Media Lab comes out with great crazy stuff. Because it's an R&D, it's funded R&D. Maybe you go back to your organization and say, hey, if we really want to fix the security stuff, maybe we get involved, and of course you can convince the marketing people and the salespeople that's a great idea also, because they're just like, ooh yeah, well this is a great way of attracting new kids out of college to come to our organization because they see our equipment, or they see our logo plastered around, and what you're doing is you're fostering and you're paying for a new security course inside these organizations and universities. I mean, heck, you as the organizations and companies are going to benefit from it, in the long run. And if you're in a company or organization that isn't intending to be around here in the long run, then what the hell do you care about security in the first place? Yep, and we'll take 2 more questions, and then we'll actually close it up. Sure. Oh, I'm going to choose somebody else other than you. You've asked too many already. Yeah.
One of the large issues beyond the credentials problem, which isn't insurmountable, is making it attractive for people who have the knowledge to come onto campus to do the work to create classification.
The statement was, the funding fills one hole, which is the equipment or the stuff, but it doesn't fill the knowledge gap. And I would task everybody that the knowledge gap might not even have to happen at the collegiate or the university level. Maybe there's a way that you can even do it in a grassroots type organization. One of the first slides I put up here under R&D is like one of my main goals is to teach. And it's to teach people how to learn. And, I might be at a particular level where I'm able to teach particular things, but that there are people at levels, no matter where you are, whether you're above me, whether you're below me, whether you're beside me, whether you're in a different, playing field, that you'll be able to educate, and you'll be able to get to think in this particular fashion. And this is another one of the paradigm shifts, going from this closed mentality. We watched CERT basically fail miserably with that closed mentality of how to store, the information, the security stuff. And, I love Marcus Raynham dearly. He's an extremely close friend of mine. But boy, we really butt heads on the idea of how do you disseminate information on things here. And I honestly think that in this case he's in the old school, and that's going to go away because the internet is designed to move information from where it isn't to where it from moving a data point from where it is to where it isn't. And as such, once you publish something on the internet, it is irrevocably published everywhere. So trying to control or to say, I'm going to compartmentalize this information doesn't work. So we better slant it and educate people while we're moving it all over the place. And so, maybe that's you going and teaching other people. Maybe that's, I saw Mike floating around, going around and teaching other people, sitting around there. And we all have to do it. It's a grassroots movement, but you try and hit it from the top, like what Miller's doing and what the OSTP is doing, and you got to try and hit it from the bottom also. So I challenge people here to hit it from the bottom, unless you're already in, the government side working on this, in which case hit it from the top. And yeah, we've already hit bottom. And I'm rambling, so it's time to go drink a beer. Thank you very much for your time.